So suppose we have two functions f and g. Well, the composition of the function g with the function f, well, we write it like this. We say g with a little circle, and that little circle means compose. So g composed of f of x is equal to taking the function g and plugging the function f inside it. We're going to look at several examples of this. First, I just want to show you the definition. And I also want to tell you about the domain. The domain of G composed with F is the set of all X in the domain of F such that f of x is in the domain of G. Okay, and we're gonna explain this in just a second. So what I want you to get from this, from the very beginning, is I'm going to give you a function f and I'm going to give you a function g. And what you're doing is you're taking g and plugging f inside that function. So let's talk about visually what this looks like. So let's say you have some domain of f. So you have, let's call this set A, and this is going to be the domain of f. And let's call this set B. And let's say you have some items in set A, whatever this domain is, and you're sending them to items in set B. Say it like that. So we have some function f that maps these items to these. So this item, let's say this is 1, 2, 3, 4, 5, something like that. You could say 1 goes to whatever that you want to call this one. You can call it 0, -3, something like that. So remember what a function does. A function takes every item in the domain and maps it to an item in the range. So this is the range of f. This B, the set B. But what G is going to do is it's going to take the range of f and it's going to send it to the range of G. So you're taking, so G is a function that has a domain and it has a range. So let's call this set C. And let's just put some dots here. So you can think of the domain of G something like this. So we have some set and the domain of G gets mapped to this set C. But what you're doing is you have a set A that's mapped. Maybe it's not all the way inside G, but partially. So you have this set B, and you can see where they intersect. They intersect here. And what you're doing is you're seeing where this is being mapped in the range of G. So maybe it's mapped here. So let me say this one more time. So you have two functions, f and g. F has a domain and a range. So the domain of f is A, and the range of f is B. Then let's call this green set I've done right here, let's call it B prime. Just give it some other name, B prime. So you have a function g that takes this set B prime, whatever's in here, and sends it to set C. So this whole set would be everything being mapped from B prime. But what you're doing when you're composing functions is you're looking to see, well, I have this set F. I have the set A, which is being mapped to a portion of B prime. Maybe it's being mapped to some stuff on the outside, but I take the intersection and I see where that's being mapped in C. So what we're doing is we're taking A and we're mapping it to this set C, and this is called G composed of F. So we start with F and then we go through G. We're going to look at some examples just so we can get a better idea of this, and maybe we'll come back to that graph in a second. So here's the first example. Remember that when you have a mapping, you have a domain and a range, and we can write the mapping in terms of ordered pairs. So let F be represented by these points. We have the point 0, 1, 2, 5, and 3, 7. So what's happening here? Let's say we have a set A, and that's our domain, and you have 3 points in it. You have the point 0, you have the point 2, and you have the point 3. Let me make that a little bit bigger. Let's move it over here. Remember that these x values are the domain of your function, and then you have a set B, and that B is given by these 3 values here. Those are the range values. So you have 1, 5, and 7. So what your function f is doing is it's sending 0 to 1, 2 to 5, and 3 to 7. That's your function f. Now here, I have a function g, and the function g is represented by these points: 3, -1, 5, 8, 7, -4, 9, 1. So you have some other, you can make it a circle, it doesn't matter. We can do that. I just was trying to go with what I did earlier, but let's make it a circle. We have some new set. Let's call this set, I was calling it B prime. We have, in the domain, we have 3, 5, 7, and 9. So let's put those numbers here: 3, 5, 7, and 9. And what G does is it's mapping to another set C. It's sending 3 to -1, 5 to 8, 7 to -4, and 9 to 1. And that is your map. I'm just going to write it like this, G. Now, let's write down the domain and the range of f and g. So the domain of f is 0, 2, 3, and the range of f is 1, 5, and 7. The domain of G is 3, 5, 7, and 9. And the range of G is -1, -4, 8, and 1. That's just given by these values here. Okay, so now we have a nice picture. Now I'm going to go back to this picture here, and I'm going to kind of do what I did here with our example. Okay. So let's draw this picture somewhere over here. Let me get myself some space. So we have the set A, which is 0, 2, and 3. Through F, we get sent to the set 1, 5, and 7. This is the set B. But then I also have, for B prime, I have the set 3, 5, 7, and 9. So I'm going to make, see, 5 and 7 is in my set. So maybe let me make this B prime like this, B prime. And inside B prime, I have 5, 7, 3, and 9. So this green set, which is B prime, is these 4 numbers. Notice that they intersect. This set B and this set B prime They intersect at 5 and 7. Now, when I take b prime, I can send b prime through this function g. It gets sent to -1, -4, 8, and 1. So let's make a set over here. Let's call this C. And the set is -1, 8, -4, and 1. Those were the 4 numbers that these 4 numbers go to. Now, 5 and 7 are inside this green set, and they're inside this white set. And 5 and 7, we have over here that 5 is sent to 8, and 7 is sent to -4. So what I have right here, that is going to be sent right here. Now let's figure out what the domain of G composed of F is. Let's put that here. Now remember the definition. The definition, let me go way back up here. The domain of G composed of F is a set of all x in the domain of F such that f of x is in the domain of G. Okay. Come back over here. So what got sent to 5 and 7? Let's review. Let's go back over here. We had 2 being sent to 5 and 3 being sent to 7. So 2 gets sent to 5, 3 gets sent to 7. Let me do this. 2 gets sent to 5, 3 gets sent to 7. And then 5 was sent to 8, and 7 was sent to -4. So 5 was sent to 8, and I think the other one was 7 was sent to -4. I'm just trying to do that. So let me write down here what's happening. We have f of 0 is equal to 1. F of 2 is equal to 5. And f of 3 is equal to 7. Then G, 0 is not in the domain of G, but 5 is, and G of 5 we said is sent to 8, and G of 7 is sent to -4. So what G does, G composed of F, the domain of G composed of F is all the x's, which the only x's that worked were these, 2 and 3. Because that 2 and 3 was sent to 5 and 7, and that 5 and 7 was sent to 8 and -4. So the range of G composed of F is these two here, 8 and -4. I hope that makes sense. So what we're doing is we're finding where these two functions, they're the domain of G, where it intersects the range of F. And we're taking that intersection and sending it to the range of G. So we're looking to see what values were sent to this intersection, which are going to be the domain of G composed of F. And then those values, where they're sent over here, that's going to be the range of G composed of F. Okay, so we found the domain and we found the range. Let's go back over here. So that's what we wanted to do. We wanted to find the domain and the range of F, G, and G composed of F. So all of that is right here. Okay, let's move on to another example. Also, we can talk about not just G composed of F, but we can talk about F composed of G. We can also say things like G composed of G and F composed of F. That's what you're going to see in the next example. So let's do that. Also, I want to mention, what is G composed of F of 2? So this is how we can check the domain of the range. So what happens, let's go through this. 2 was sent to 5, and 5 was sent to 8. So G composed of F takes 2 to 8. So it's like skipping this middle step. 3 was sent to 7, and 7 was sent to -4. So G composed of F of 3 is -4. So what we're doing here, which was like the definition that we saw earlier, G composed of F of X, is G with F of X plugged in. So another way you can think of this is G of F of 2 for this first one here. Well, 2 was sent to 5. So it's like plugging in 5 into your function because F of 2 is 5. And we said 5 was sent to 8. And so, like I said, it's skipping this middle step. G composed of F of 2 says 2 goes to 8 because 2 went to 5 and then 5 went to 8. G composed of F of 3 is G of, well, F of 3. 3 was sent to 7. So that's G of 7. And then we know 7 is sent to -4. So G composed of F of 3, 3 is being sent to -4 because start at 3, then you go to 7, and you end at -4. Okay. Now if we tried to do something else like 0, well, 0 is sent to 1, but 1, that's not in the domain of G. So 1 is not being sent to this other side, in the side over here. And because of that, that's why it's not in the domain, because we don't have a mapping. We don't have anywhere to send 1 to. Because 1, if you remember, look over here, our domain doesn't have a 1 inside. So it can't be in the domain of G composed of F because we would have to have a place that 1, that number here, the 0, which is sent to 1, that 1 would have to be sent to something over here, and it's not. So it's not in the domain. Now the range of G is 8, -4, -1, and 1, but the range of G composed of F is where this intersection, where that's sent, and it's only sent to these 2 items.